Hi, welcome to YourPedia. Now we will discuss NPTEL assignment questions, and in this you discuss analog electronics questions, right? So in this now I can able to examine one of the question, that is nothing but question number 119 here. So what the question is given means, in the monostable multivibrator shown in figure, VCC is equal to 5 volt. So collector supply voltage equal to 5 volt and C equal to 50 microfarad. When a negative going trigger pulse is applied, we want to get a 1 second output pulse. What is the value of R equal? What is the value of R? You can able to discuss now. Check up the question now. What is say? In the monostable multivibrator shown in the figure, VCC equal to 5 volt and C equal to 50 microfarad equal. And when a negative trigger pulse is applied, we want to get a 1 second output pulse. What is the value of R is appropriate equal? Approximate value of R is asking. So this is the 555 timer circuit is given. So this internal block diagram of 555 timer is given, and now the corresponding monostable multivibrator is externally applied with what sir means resistor and capacitor, and the option C given is 22 kilo ohms, 26.9 kilo ohms, 15.5 kilo ohms and 18.2 kilo ohms you can call. Now let us see this one now. What is the thing of this? We can able to check out. Now I can able to check out the answer for this. So now I can able to go through this one now. What is the one? First I can able to examine about 555 timer. So 555 timer containing, right, what sir means built in with 2 comparators. This is one of the comparator. This is another comparator you can call. So 2 comparators, right? So you know that any comparator can able to changing that output depending on the comparison of that corresponding input voltage with some reference you can call. So here one of the comparator input is a threshold value whose reference is a 2/3 VCC. For another comparator, the input value is a trigger voltage whose reference is 1/3 VCC you can call. So according to this circuit design, this comparator can able to generate a reset trigger pulse, when the voltage applied at threshold terminal greater than 2/3 VCC you can call. So the reset, the output of this comparator can drive the reset input of RS flip-flop here you can call. So this comparator can generate a reset trigger pulse when the threshold voltage is greater than 2/3 VCC. And you know that this is an RS flip-flop. So in the case of RS flip-flop, the output become reset when the reset input is a high. Reset means output become low. Got it now? Next, one more comparator is there. That comparator can drive the set input you can call. So this is the one more comparator that can drive the set input of RS flip-flop. So when it can drive set to trigger pulse means the corresponding trigger voltage compared with 1/3 VCC you can call. So this is the corresponding trigger voltage that is compared with what sir? 1/3 VCC now. So whenever that corresponding trigger voltage come below 1/3 VCC, corresponding trigger voltage come below 1/3 VCC, the output of this comparator is a high, that is the set input is a high, so that output becomes set. And so now, so this corresponding comparator can able to generate a reset trigger pulse. This corresponding comparator can generate what sir? Set to trigger pulse you can call. Just I can name this one to you. What is that one? Comparator, suppose I can call this is comparator 1, right? This is called comparator 2 I can call. And so now check up 1. So that circuit is IC 555 timer there. It is what sir? IC 555 timer, monostable multivibrator it is. IC 555 timer, monostable multivibrator. Okay. So it has built in with what sir means 2 comparators. There I told in our diagram, comparator 1 having threshold input compared with 2/3 VCC. According to this one now, when threshold input greater than 2/3 VCC, it can generate a reset to trigger pulse to keep that output as a low, right? comparator 1 can generate a reset trigger pulse, right sir? So it generates a reset trigger pulse when what you say means in our circuit diagram you check up there, the corresponding threshold input is greater than 2/3 VCC, you can call. When threshold input greater than 2/3 VCC, so that output is reset. Output is what sir? Reset, you can say. Whereas comparator 2, their trigger input is there in our diagram, can generate a set to trigger pulse. Confirm now sir? Can generate a set to trigger pulse when trigger input come below 1/3 VCC. So on compared with the reference of 1/3 VCC, whenever the trigger input come below 1/3 VCC, the corresponding comparator 2 can generate what sir means? The set to trigger pulse you can call, so that output is a set. So that output is a set sir. Condition for set and condition for reset I told you. Remember now? You check up in this circuit diagram again. So the external circuit elements that you connected for IC555 monostable multivibrator is only resistor and capacitor. Resistor and capacitor. And here the discharge terminal is there. What is the job of this discharge terminal means? This discharge terminal can allow this external capacitor to discharge through it. This external capacitor can allow this corresponding, this discharge terminal can allow this external capacitor to discharge through it, you can call. Sir, the discharging of capacitor should be done through this discharge terminal. Confirm now? So now I can able to indicate what is the circuit diagram of this one now. I can able to check out that corresponding diagram. See this one now sir. This is your IC555 monostable multivibrator sir. It is originally 8-pin package used. So there at pin number 3, you take the output sir. This is the place for output V0. Confirm now. And pin number 1 go for ground sir. This is pin number 8 and 4. 4 is a reset pin. 8 is a VCC supply. You can apply VCC. Got it now? There you see this one now. 7 is a discharge terminal there. 7 is a discharge terminal. 6 is what sir mean threshold terminal. 2 is the trigger input. So this is the discharge terminal you call, through which the external capacitor can discharge. 6 is threshold you can call. 6 is what sir? Threshold you say. This is the threshold input sir. 2 is the trigger input there. Confirm now sir? 2 should be the trigger input. Now what are the external elements you connected there? You check up in the question he given. So threshold input and VCC supply you are connected to resistor sir. But that you can connect it in ground is nothing but a capacitor sir. That I do it now. So between VCC supply and that threshold terminal you are connecting what sir means VCC supply. So this is VCC supply sir. Between threshold and threshold and VCC supply you are connecting a resistor sir. This one. This is a resistor. So this one should be shorted to be like this. Confirm? And here you are connecting what sir means capacitor. Capacitor should be connected there. So you are applying some negative trigger pulse. This one. So this is the circuit diagram of your IC555 monostable multi-vibrator. He asked that to get an output pulse width of 1 second, what the value of R is required. Some C value is given, sir. C equal to how much is there? He given, you check up there. So in this question, he given the value of C, sir. That C equal to 50 microfarad is given, sir. To get a 1 second output pulse width, what is the value of R is required, he asking, sir. Right? C equal to how much? 50 microfarad is given. Check up now. This given is 50 microfarad, sir. Let us see this one now, how it can work. I show that one to you, simple thing. Sir, as long as you don't apply any trigger pulse, the output should be in the stable state. Right? The output look like this stable state here, sir, as long as you don't apply any trigger pulse. Suppose I assume that the first trigger pulse I show here like this, sir. This is the applied negative trigger pulse at a trigger input, sir. Right? One trigger pulse I consider. Now I can go for the output voltage and capacitor voltage, sir. Suppose this is output voltage I show to you. And this is capacitor voltage, sir. Both of that I can go. Right, sir? 0. And you remember now, sir, capacitor going to be charging to a highest value here is nothing but what, sir, means threshold voltage, sir. That equal to how much means 2 by 3 VCC, you know. This one reference is 2 by 3 VCC, sir. Trigger input reference is 1 by 3 VCC, you know. Confirm now, sir? So now I can able to take out that reference of this. This is 2 by 3 VCC reference, sir. Confirm? Now I can able to check out, sir. This is the first one. Before applying a triggering pulse, sir, before applying the triggering pulse, you remember that in the case of monostable multivibrator, the output should be stable state. The output should be in the stable state, right? That stable state, it is nothing but low. How do you say it is low, sir? That I can able to confirm to you. Sir, as long as the output is low, you can confirm here. If the output is low, sir, this discharge transistor is on. The discharge transistor should be like on, sir. Whenever that output is low, the discharge transistor is on and allowing the capacitor should be discharged. Allowing the capacitor to go forward, sir, discharge. And so now, as long as the output is low, what you can call, sir, means the discharge transistor is on, sir, indicating that the capacitor go for discharging. But here you see this one now, initially the capacitor is empty, sir. Initially the capacitor is empty, so that it do not discharge anything, sir. It do not discharge anything, so that capacitor voltage remains same as 0 like this. Originally here capacitor go for a discharging, sir, but already capacitor voltage 0, sir, no chance of any discharging. So capacitor showing what, sir, means 0 volt only. This is the first one. Now I can able to go, sir, first to triggering pulse. Sir, the voltage applied at a trigger input is a negative pulse, sir. Here it is 1 by 3 VCC. So the applied triggering voltage should come to be less than 1 by 3 VCC. According to your condition, sir, you know that the output become high. The output become high. Applied voltage at the trigger input less than 1 by 3 VCC. So immediately the output become high. I think that, you know, triggering pulse is a short duration pulse, sir. The output become high. That is a set. How much, sir, means it is 5 volts, sir. VCC some 5 volt you can call. So that become as a 5 volt. What is the voltage VCC given? That should be there, high value. Now you observe now, sir. Whenever the output is high, what the thing of the discharge transistor, sir? So this one now, discharge transistor is open, sir, whenever the output is high. Under that condition, this capacitor go for charging from VCC supply, sir. VCC supply is given some 5 volt. Now the capacitor starts charging, sir, from VCC through the resistor. Sir, the charging of a capacitor through resistor is exponential, you can call. This is the charging of a capacitor, sir. So at a particular time, the voltage crossed by the capacitor is nothing but crossing 2 by 3 VCC. At a particular time, what do you find out, sir? Means the voltage of the capacitor reached just to cross 2 by 3 VCC, you can call. So this is the particular time I can call where the voltage across the capacitor cross what, sir? 2 by 3 VCC. See this one now, whenever the voltage of the capacitor just cross 2/3 VCC, then you see this one now, the threshold voltage crossing 2/3 VCC, immediately the output become low. Confirm now, the applied capacitor voltage equal to threshold terminal voltage there. The voltage across the capacitor cross 2/3 VCC means nothing but the corresponding comparator keep that output as a reset. You know that our reset means output become as a low, sir, like this. Output become low. So this is again be a stable again. So this state is a temporary state, sir. On applying a triggering pulse, it can go for a temporary state. And that should be stay in temporary state for a fixed time. I think that you know that fixed time purely depending on the charging of capacitor. Now the output becomes stable, sir. Output is low. Once the output is low, discharge transfer is on, sir, allowing the capacitor to discharge through a discharge terminal like this. Sir, the discharging of the capacitor through a discharge terminal without resistor is there, so that the discharging should be done very fast without requiring any time. So because the discharging done through discharge terminal without any resistor, sir, like this. So it is discharging to 0, sir, and continuously it's 0, right, until next triggering pulse comes. So this is the discharging condition, sir. This is the charging condition. Commonly, this IC555 monostable multivibrator is used to get a required pulse width, sir. Required pulse width, very accurate pulse width, sir, and most popular to use in microprocessor and microcontroller applications, you can say. So the output pulse width is equal to the charging time of the capacitor, sir. Is equal to what, sir? Charging time of capacitor. Because discharging time 0, charging time, sir. T equal to TC, you can call the charging time. Pulse width T equal to TC, sir. Sir, from CR circuit, you know that how to calculate that to TC, sir, means this one. We know the formula with initial voltage of the capacitor 0, sir. VC equal to Vmax into 1 minus e power minus T by RC, sir. So VC equal to how much, sir? 2/3 VCC, you can call. Vmax equal to VCC, 1 minus e power, sir, T equal to TC, TC equal to T, sir, charging time, that equal to pulse width, you can call. Pulse width is calculated only during what, sir, means a temporary state, this one. So by minimizing this, you are getting the output pulse width T equal to what, sir? 1.1 RC seconds. T equal to 1.1 RC seconds. He asked that to get a time pulse width of 1 second, right, how much R you require? And C is given some 50 microfarad. Right, sir? So formula is T equal to 1.1 RC seconds, R equal to T by 1.1 into C, sir. T is 1, sir. 1.1 into, this is 50 into 10 power minus 6. Confirm now? So this becomes how much, sir, means 55, you can call. 1 by 55 into 10 power 6 ohms. Sir, if you minimize this, you may get it is 18.18 kilo ohms, sir. Around 18.2 kilo ohms. So approximately it is nothing but how much, sir, means 18.2 kilo ohms you require to get an output pulse width of what, sir? 1 second there. To get an output pulse width of 1 second, how much you require, sir, means 18.2 kilo ohms. So the corresponding value equal to how much, sir, means D answer. Sorry. So what is the corresponding answer for this one, sir? Means D. Right? So to get an output pulse width of 1 second, how much is the value of R you require, sir? That to be equal to what, sir, means D. 18.2 kilo ohms. Understood now this?